Hello and welcome back for part two of our fractions video. We're operating with fractions. In part one, we went over, basically what a fraction was, reducing, and then adding and subtracting fractions. In this part, we're going to be multiplying and dividing, which are similar but not exactly the same. So just jumping right into multiplying, the process for multiplying is just what it says here. You multiply straight across and then reduce, which we've already covered. Basically, you're dividing the numerator and denominator by the greatest common factor, or dividing by a number over itself, which is 1. So again, not changing the value of that number, just making it simpler. So with multiplying, that's kind of the nice thing. I mentioned in the last video that adding and subtracting is actually probably the more difficult of the operations, just because you have to have a certain condition met first before you can actually start, and that is that you have to have a common denominator. With multiplying and dividing, that's not the case. I should say with multiplying, that's not the case. You go straight across and multiply, and that's it. And then all you got to do is reduce. So 3 times 2 is 6. 8 times 5 is 40. And then all you have to do is reduce 6 and 40. So you got to divide the numerator and the denominator by the same number, so something over itself. And the quickest way to do that is to use the greatest common factor. So the greatest common factor of 6 and 40, really the only common factor other than 1, is 2. So dividing by 2 over 2, which again is just like dividing by 1. 6 divided by 2 is 3. 40 divided by 2 is 20. Double check to see if 3 and 20 will divide anymore, but they won't. 3 is prime, and it does not divide evenly into 20, so there you go. 3 over 20 is your final answer. So that's the nice thing about multiplication. You just go straight across and then reduce. Simple as that. Okay. There is even one way to shortcut multiplication, actually. Okay, you can always just multiply straight across and then reduce. Or, for example here, you can reduce before you even multiply the numbers out. Okay, sometimes you'll see people do this and they'll go, oh, 3 over 3 cancels, and then 2 over 4 will reduce. They both divide by 2, and then you can multiply across. I'll explain that. So if I was to do this, if I was to do 2 over 3 times 3 over 4, essentially what we're doing is we're multiplying the numerators together, and we're multiplying the denominators together. Okay? So let me rearrange this to where the 3's are over top each other. So instead of 2 times 3, I'm going to say 3 times 2. You're allowed to change the order in multiplication. It's called the commutative property. It also works with addition. The order does not matter in multiplication and addition, but it does matter in subtraction and multiplication. However, so I now have 3 times 2 over 3 times 4. Well, if I'm going to if I'm going to multiply this by a factor of 3, and then also divide it by a factor of 3, those are inverse operations that are going to cancel each other out. Okay? Or you can think of this as, oh, I'm just multiplying by 3 over 3. I'm multiplying this by 1, so that really doesn't change the value of anything. Hence, I'm able to cancel. I'm planning on making a video about this because some people don't quite understand what canceling means, and it means different things in different situations. So with multiplication, if you have the same number over itself, it will cancel. It will divide out into 1, which when you're multiplying does not change the value, so it's not necessary to have there. It's like saying 1x when you can just say x. Unnecessary. So in this case, telling you what, in this case we have 3 times 2 over 3 times 4, 3 over 3, will end up canceling out. And then you can just take 2 over 4 and reduce that, dividing both by numerator and denominator by 2. You get 1/2. Okay? So if you see a fraction like this, or fractions like this that have a common factor in the numerator and denominator, it does not matter, oh my goodness, it does not matter which fraction it's in. When you're dealing with multiplication, if you have a numerator and denominator that match, you can eliminate them, you can cancel them out, as well as if you have a numerator and denominator that will have a common factor, you can reduce them by that common factor off the rip. So all this being said, I swear OneNote's going to drive me crazy. All that being said, when you see a situation like this, yes, you could multiply and get 6 over 12 and then reduce to 1/2. Or what you can do, oh my goodness, what you can do is reduce on the front end and say, oh, 3 divided by 3 will be 1. That'll cancel out. Or you could put 1 and 1 if you want to, 1 over 1. And then 2 over 4, I know will both divide by 2. And so now you just have to multiply 1 times 1 and 1 times 2. And you've got your final answer before you even have to reduce anymore. So it's up to you how you want to do it. This makes a lot more sense when you are dealing with larger numbers. When you're dealing with big numbers, it makes sense to reduce on the front end because, you know, otherwise you're going to be multiplying them and making even larger numbers. And then having a lot more reducing to do on the back end. So sometimes that front end reduction will help, but just something to pay attention to, something you're able to do with multiplication. It does not work with addition unless the fraction is, you know, by itself, not reduced. But multiplication, pretty simple. Multiply straight across and then reduce. And then you can always cross reduce if needed. And then one more example. Just as a reminder, when you're dealing with something like this, I've seen a lot of students who will multiply a whole number by a fraction by multiplying both the numerator and denominator by that whole number. That's breaking the rules. Because what you are technically doing there is not multiplying by 3, you're multiplying by 3 over 3, which is not the same as just 3. 3 over 3 is 1, if you remember anything we've done so far. Okay, so 3 over 3 is 1. 3 by itself is just 3. If I want to make this into a fraction, just slap a 1 under it. Okay, any whole number is just over 1. It's divided by 1. So please make sure you're not just making up your own rules. And then we can go ahead and do our normal thing. 3 times 4 is 12. 1 times 5 is 5. Then we try to reduce. This one will not reduce. 12 over 5, because 5 is prime, and it will not divide evenly into 12. It's not a factor of 12. So that is okay as it is. I mean, you can make it into a mixed number, but I prefer to leave things as improper fractions, because in algebra, most of the time, it's unnecessary for a mixed number. All right, so just don't forget about whole numbers being over 1. Okay, last but not least, division. And really, again, the nice thing about division is it's just multiplication in disguise. So what we're going to do when we have division by fractions, we're going to keep the first one and leave it alone, keep the first fraction, change the sign to multiplication, and then flip the second fraction over. We're going to use its reciprocal. Okay, a lot of people refer to this as keep, change, flip. KCF, not to be confused with KFC, the popular chicken franchise. But keep, change, flip is the way to remember this. Keep, change, flip. So that's what we're going to do. We're going to do 4/5 divided by 2/3. We're going to keep 4/5 and leave it alone. We're going to change the sign to multiplication, and then we're going to flip 2/3 into the reciprocal, 3 over 2. So all we have now is 4/5 times 3 over 2, and we just multiply. 4 times 3 is 12. 5 times 2 is 10. And then don't leave it alone without reducing. 12 over 10 will reduce. These both divide by 2. Remember, you're always just dividing by 1. That's all you're doing. Not changing the value. 12 divided by 2 is 6. 10 divided by 2 is 5. That's your final answer. Okay? So keep, change, flip. The reason that works, let's think about this. I'll do a simpler example. And I won't even mess with a fraction here. Let me just do 4. Let me actually do this. 4 times 1/2. Basically what I'm saying is I'm taking half of 4. I'm multiplying 4 by half. I'm taking half of that number. So if I flip, or if I keep, change, flip, I keep 4. Well, I explained that backwards, but I'm gonna stay with this. Let me go ahead and let's just try this again. 4 divided by 2. Okay, let's treat this as a keep change flip. Let me do it this way. Let's keep this as a keep change flip. 4 divided by 2 we know is going to be 2. We're taking half of that. So 4, change the sign, flip 2 over to its reciprocal. 2 over 1 switches to 1 over 2. Okay, 4 times 1 is 4. 1 times 2 is 2. Comes out to be 2. That's why it works the way it works. That may not have been the best explanation because I kind of did it on the fly there. But you can always think of it the other way, like I was starting it off. 4 times 1/2. If I was to reverse this and put it back in division, it's the same thing. 4 times 1/2 is the same thing as saying 4 divided by the reciprocal of 1/2, which is 2. So when you change multiplication, you can just flip the second number into the reciprocal and vice versa. All right, so sorry if that confused anybody. Like I said, I did it on the fly, but I am running out of time here, so I'm going to go ahead and do the last example. 8 over 3 divided by 4. Again, we have an improper fraction, 8 over 3. Totally fine. Division, so we know we're going to keep change flip. And then we have a whole number, 4. Okay, don't forget about what we do with whole numbers. We just put them over 1 when we're dealing with fractions. So if we keep change flip this, I swear OneNote's going to drive me crazy that way it bounces around. If we keep change flip this, we're going to keep 8 over 3, change the multiplication or the division sign to multiplication. OneNote wants it to be a circle, but that's okay. I'm going to fill it in. And then we're going to flip the 4, or 4 over 1, to 1 over 4. So don't be confused by the whole numbers. Put them over 1 whenever you're dealing with fractions. And then, like I was talking about before, you can multiply straight across and reduce, or if you see something beforehand that will reduce, you can always do that as well. So I see an 8 on the top here and a 4 on the bottom here. I know that numerator and that denominator, oh my goodness. I know that numerator and denominator will both divide by 2, so 8 divided by, we'll both divide by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. So it makes my life a little bit easier right on the front end, because now I'm multiplying by 1 over 1, which is just 1, and 2/3 times 1 is 2/3. 8 and 4 both divide by 2, but I divided by 4 because it's the larger of the factors that they'll both divide by, so it'll do the job in one go. So yeah, you could have divided them by 2, and that's fine. You just would have had to reduce some at the end. But again, 2 times 1 is 2, 3 times 1 is 3, and there we have it. So I could have multiplied across from the beginning. I chose to cross-reduce just to remind you. Hopefully that helps, guys. That's what I'm here to do. As always, let me flip back up to the top. YouTube channel, email address if you feel like you want to shout out an example or a suggestion of a video you'd like to see, or you want me to expand on something, or you didn't get one of the examples I did. I'm happy to do a video on that, or to respond to you with an explanation, whatever works best. So have a great day. Hopefully that helped, and we will be back with another video soon. Stay tuned.